In this video, we're going to talk about 3.4 Objective 1, where we identify how a graph is misleading. So let's go ahead and take a look at our first question. The labels on the given figure indicate that the $2021 was worth 0.31 cents in 1981 dollars. Use a ruler to measure the length of the $2 bills in the figure. Do the lengths accurately reflect the change in value? In what way is the graphic potentially misleading? So the lengths accurately reflect the value shown, but the graphic can be visually misleading because our eyes tend to focus on the area rather than the length. So because we have reduced the length and the width of the dollar bill, then we have actually reduced the area much more than what we intend people to see. We intend people to see that this length is about a third of this length, and that this length is about a third of that length, but a third times a third is a ninth. And our eyes look at this and say, oh, there's about 9 of these. Probably not even going to draw it very well. Yeah, I messed up, but there's about 9 of those $2021 in the $1981 is what our eyes would see, and we would say, oh, it's about a ninth of the value because 9 of these could fit into there. So the graphic is misleading because we wouldn't understand that we were only supposed to look at the outside dimensions and not the area. Weekly instruction time for a school student in one country is 20.2 hours compared to 29.9 hours in another country. Is the difference meaningful? And how could a graph be constructed so that the difference is greatly exaggerated? So the difference of 7.7 hours is meaningful. To exaggerate the difference, use a bar graph and start the vertical scale at, say, 20 hours. If you skip the portion from 0 to 20, and you do a little, we'll see this symbol sometimes where you do this thing that looks like a little lightning bolt here that shows that you skipped some stuff and that you go straight from 0 to, and then you put right here, you have this little lightning bolt thing and you start with 20. Then you have compressed it and you exaggerate the difference. This bar looks like it's nothing to get to 22, and then 29 is way like that, and that just looks huge, as opposed to if we did 0 to 20 would be like this, and 0 to 29 might be, like another 50% of that or so might be that, and that's significant, but it doesn't look nearly as bad as if I give almost no height to the first bar because I start my y-axis on 20. So that's a trick that's used a lot with graphics to compress the y-axis like that. Don't fall for that trick. In fact, here's an example of it right here where we start the y-axis at 50. And so this bar actually has 50 below it, and this one has 50 below it as well. And then you see that maybe this is misleading because it looks like there's a 300% difference here, whereas really there might only be like a 200% difference here, and maybe there's only a 50% difference or something like that. So let's go ahead and how is the graph misleading? The graph is misleading because the vertical axis scale does not start at 0. How could the bar graph be drawn to not be misleading? By starting the vertical axis scale at 0, the graph would not be misleading. And the way in which it's misleading is the relative the percent change. There appears to be much larger than it should be. The figure depicts the amounts of daily oil consumption in millions of barrels in the United States and Japan for a recent year. Does the illustration accurately depict the data? Why or why not? So we have the values here of 19.82 millions of barrels, and this says 4.51. And these are supposed to be 3D objects here where we're supposed to, or we would imagine that we're talking about volume here that's 3D. So they say, no, this is not a good depiction of the data because the graph incorrectly uses objects of volume to represent the data. We shouldn't do that because we can't really imagine that volume very well. We should try and stick to line graphs, bar charts, things like that to make comparisons, because we can't easily see how many of these we can stick inside of this. It's hard to do that with volume. All right, that's it for this video. We'll come back next time and talk about 3.4 Objective 2. See you for the next video.